In this lesson, we are going to talk about 2D milling and the basic Fusion toolpath parameter dialogues. 2D milling is a planar machining process. It's sometimes called 2.5-axis machining because all the cuts are limited to a 2-axis plane, normally the XY plane, and then the depth cuts are taken in the third axis, normally the Z-axis. When you select the 2D pull-down, there are a variety of toolpaths to represent this type of machining. This lesson will focus on the face toolpath. Face, or facing, is the process of milling the rough stock off the top of the part to make it flat. You'll find many of the parameters for face will be similar to other toolpaths. The dialog is divided into 5 tabs. The Tool tab is where you can select the cutting tool, type of coolant, and define the cutting feeds and speeds. The Geometry tab is where you can select the boundary or area to be machined, the stock area, and possibly areas to exclude from machining. These options will change depending on the toolpath you selected. But generally, the Geometry tab is for making a selection of the cutting area. The Heights tab is where you can set all the Z position heights for the rapid clearance, the top of the part, the retract position, and the bottom of the cut, or final depth. The Passes tab contains cutting parameters, the width of the cut, multiple depth cuts, stock to leave, and toolpath smoothing to filter smaller steps into arcs and lines. These parameters will vary the most depending on the selected toolpath. The Linking tab controls how the tool will position between interrupted cuts. This is how the tool positions when the cutter must retract from a cut and position for the next cut. These parameters also control how the tool will blend onto the cut and blend off of the cut using the leads and transitions. Again, there will be some minor variation between these parameters depending on which toolpath strategy is selected. In these lessons, we will not be discussing every parameter, since most of the time the system defaults will produce an excellent toolpath requiring few changes. Let's go back to the Tool tab and define our facing cuts for this part. Press Select to enter the tool library. The tool library dialog is divided into 3 general sections: the available libraries shown on the left, the tool filters and tool information shown on the right, and the available tools shown in the middle. The Documents section in the left will show the currently open projects. The Sample section shows the number of tool libraries included with Fusion. The Local section shows any custom libraries you might have created. This sample part has tools already selected. If you click on the document heading Intro to 2D Machining, the middle section will show only the tools for this project. Pick tool number 1, the 2-inch diameter face mill, from the list and press Select. For now, we will leave the default speeds and feeds for this tool. The tool library will be discussed further in another lesson. Let's go to the Geometry tab. This is where you would normally select the profile to be machined. For face milling, we generally want to clean off the entire top of the stock. Fusion assumes that and shows the stock boundary. If you mouse over the group heading or an individual parameter, a tooltip will appear. This tip explains that there is nothing for us to pick unless we want to select a specific area to face. If you mouse over the Stock Selections box, the tooltip explains what you can select and how the toolpath results might look. Keep an eye on the tooltips. They contain an abundance of useful information. With nothing to select here, let's move on. Let's go to the Heights tab. The Heights tab is for setting clearance positions and depths in the spindle axis, normally the Z-axis. The clearance height is the fully retracted position above the part. It represents the safest height the tool can position. This is the Z height for the first rapid position and the last height after the toolpath has been completed. The retract height is the intermediate position, where the tool retracts between cuts when taking multiple cuts on a profile or pocket. The feed height is where the tool starts its feed move to the cutting depth or the start of the pecs for multiple depth cuts. Normally, this is a minimum distance above the material to be removed. The top height defines the actual top of the surface to be machined. It's the top of the material to be removed. The bottom height is the final cut depth. Each of these heights can have a different reference. Some positions will be in reference to the model. Some will be in reference to the stock you defined in the setup. Some heights can be in reference to other heights. So when you specify the offset value for the heights, you could also describe what it's in relationship to. Mouse over the From input, and it will display your reference options. It's best not to think of these as an absolute Z position, but rather a reference to the model. This is the benefit of an associative toolpath. If the model changes, the heights can maintain their reference. You can also adjust these height offset values if you grab one of these colored rectangles and drag them up or down. You may notice that grabbing the retract height rectangle and moving it up will change the clearance height. That's because our clearance height is in reference to the retract height. So for this lesson, I don't need to adjust any of these parameters. The top height is in reference to the stock top, and the bottom height is in reference to the model top. So however much stock we have on the top of the part is how much it will be facing off. The Passes tab information will determine how much it takes per cut. Let's go to the Passes tab. The Passes tab will control the cutting steps, and these parameters will be more specific to the selected toolpath. In this case, with facing, we can control the pass direction of the first cut, the pass extension off the edge, the step over between cuts, and if it should cut in both directions or only one way. I'm going to set the pass extension to be 1 inch, which is half the cutter diameter. And I'm going to set my step over to be 1.8, almost the full width of the cutter. Remember, our block is only 1.75 inches wide. That should allow me to take a single cut across the top face. There are other parameters we can use to control the facing, but this is all we need for right now. Let's go to the Linking tab. Linking controls motion between multiple cuts. If the toolpath is generating many small cuts, that may create many retract moves. You can limit the number of retracts and how it transitions between the cuts using these parameters. If the area has many ribs or pockets, you may need a full retract to the clearance height. If the area is generally open, there may be no reason for a full retract. By evaluating the distance from the end of one cut to the start of the next, Fusion can determine if a full retract should be output. By increasing the maximum stay-down distance, you can reduce the number of retracts and instead replace them with feed moves to the start of the next cut. In the tooltip, you can see how increasing the maximum stay-down distance keeps the tool closer down in the cavity. Staying closer to the cavity will most likely reduce the cycle time as well. The Linking tab also contains the leads and transitions. This is how it's going to lead onto the first cut or lead off of the last cut. Set the lead-in value to 0.2. This is a vertical lead-in radius, which is preferred for leading into a very tight area. Press OK to generate the toolpath. In this lesson, For the facing toolpath strategy, we learned how to select a tool from the library, select a cut boundary, set our clearance and cut heights, set our cutting step over, and control the cut transitions. Press Ctrl S to save the part, Command S on the Mac.